Hi, and welcome to this next tutorial on how to analyze images using the Pecan plugin in Fiji. So for this tutorial, we're going to use sample image 3. Like a composite image. So let's take a look at this image and devise a strategy. And as you can tell, this is a pretty different image from the ones we've done in the past. We've got 3 channels. One is just a nuclear stain with DAPI. Then we actually mark the genotype of these cells using a nuclear GFP. And then we have a staining that seems to cover the entirety of the cytosol and mark out the membranes as well. So we have to kind of come up with a strategy here. So first off, this sort of cytosolic membrane staining is kind of uneven. So I don't think we can really do a 3D analysis of it, or I don't think a 3D analysis would be very effective. So what we're going to do is we're going to do a Z projection on this image. And then we have to figure out how do we identify the entirety of this region as one genotype versus the entirety of this region as being another genotype. And the way we're going to do it is we're going to identify this genotype marker, and we are going to use a tool that's built into Pecan called seeded region growing. And that's going to allow us to identify this region as one genotype and these 2 regions as another genotype. So the first thing we got to do is make ourselves a Weka classifier. So let's make one for this guy over here. So let's duplicate this channel out. It's going to be channel 2. Now launch. We're going to Z project it down because that's how we're going to analyze it. The sum projection. Now let's launch the Weka segmentation. And this time we're going to do it in 2D. Now this is pretty straightforward. That's our background. Remember, background always has to be class 1. And our genotypes are going to be these guys here. Train the classifier. So because this is just one image and we're using the 2D Weka segmentation, this should be faster than doing it on a whole 3D image. And as you can see, it's doing a good enough job for our purposes. So actually, I'm going to make it a bit more precise just to make sure there's less background on this. We can be pretty conservative because we don't actually have to segment the whole thing. I'll show you why in a second. So I want to make sure that these guys are nice and separated. Then we train the classifier again. And you see that was pretty fast because it's a relatively simple image. And now let's create a result. And it's done a pretty good job. So let's save this classifier to the desktop. And this is going to be and now we need a second Weka classifier for this example. And we're going to do another one for channel 3. And so let's duplicate this out. You can either press Control-Shift-D, or you can get it from the command menus, which is image duplicate. Just duplicate channel 3. And again, we're going to sum project this down. And launch the Weka classifier. And again, our background, all this. Our signal. Hit train classifier. And that seems to have done a pretty good job. And you'll notice there's a little bit of speckles around the edges, and those little speckles will be taken care of. We just automatically, with Pecan, do a bit of a despeckle on these images when we've done a Weka classifier. So let's save this classifier as...
Okay, so now that we've made our classifiers, let's load them into our software. So run Pecan, and to make sure that we don't have anything weird lurking from one of the previous examples, let's restore our default settings. Now we just have to load in our classifiers. So we're going to add in a new Weka classifier. This isn't 3D because we did a 2D image. Just like that, and press OK. Now let's give it a name. Load it. Okay, now that's taken care of. See, it's found here now. And now let's add one for our nuclear GFP. And if you upload it into Weka using any of these options, you can access it from all of the different choices. For instance, you'll see that we can now, if we wanted to do single cell tracking, we could also use the nuclear GFP model for single cell tracking. But we're going to keep this disabled for now. And we're going to turn off the caspase analysis as well. So now we've just got our nuclear GFP quantification Weka model and our cytosolic stain Weka model. The cytosolic stain is our third channel, so we have to set that appropriately, and our nuclear GFP model is the second channel, that's going to be a G. So I'm going to run this without the seeded region growing first, just so you can see a sense of, to give you a clear sense of what the seeded region growing does. It's going to be example 3. Press OK. We don't have to specify any ROI here because it's going to be, oh, I forgot an important step. Press escape if you ever want to get out of the plugin. We are Z projecting it down with the sum projection to basically get rid of turn it from a 3D image to a 2D image. I almost forgot that. So you don't have to specify any ROI because we've told it that the Weka classifier is going to choose the ROI for us. So just press OK, unless you want to change some of the Z-planes. And this won't take all that long just because it's a 2D image rather than a 3D one. And that's how long it took. Let's go and see how it did. And this is what you can see. Our classifier basically did what it was supposed to do. It's identified our green nuclei. And it's also, the ROI has pretty effectively selected out what would be the sort of membranous regions. So what we're going to do is we're going to use this technique called seeded region growing so that we can identify this entire region here as being sort of our membranous stain. So to do that, launch Pecan again. And we're going to go do Advanced Clone Segmentation Parameters. We're going to add a seeded region growing step. So basically what we're going to do is we're going to take the channels that we've segmented and we're going to apply those as seeds to a different image. So we're going to apply it to the ROI mask. So basically whatever we select with the ROIs. And press OK. And we're also going to measure fluorescence intensity. So just tick this box to turn on fluorescence intensity and choose whichever channel you want that to happen on. And this is just going to measure the fluorescence intensity within the clones. It's going to be the third channel. And let's just restore our saved ROIs. And we'll run it again and see how this differs. And now it's done, and let's see how it compares. As you can see, now instead of just segmenting out the nuclei, it's segmented out this entire region. And that's because we segmented the green nuclei, and we use those as seeds that we're going to expand to just fill this entire area that's been segmented out by the ROI. So now we have a really accurate clone segmentation of this genotype over here versus these sort of unlabeled cells over here. And the fluorescence measurement is going to be basically the clone region here versus the not clone region here. So we have a fluorescence measurement for how intense this sort of blue staining is in the two separate genotypes. And that's how you can use seeded region growing to sort of expand the functionalities or the types of images that you can analyze. And you can use seeded region growing for any of these kinds of analyses, for clone analyses or for single cells, just anything that works for you.